Hi students, I'll try in this educational video to technologically introduce the steel beam resistance under the Shear ultimate limit state criterion, of course as simply and as clearly as possible. Okay, let's go. Well, the shear force ultimate limit state criterion is expressed by the Eurocode 3 standards associated to the European standards 1993 as VED divided by VCRD should be lower than 1. This means that VED, which is the design shear force, should not exceed VCRD, which is the cross-sectional shear resistance. It's to note here that the design shear force VED is associated to the maximum shear force applied on the considered beam, and it can be determined based on the table that you see now in this slide. You can notice in this table that the shear force or the applied shear force depends on the load case. This table presents 5 load cases, and there are another tables presenting the other load cases. You can notice, for example, here that for a beam with a length L and supported by 2 hinges in the points A and B, and the beam is subjected to a distributed load denoted by Q, you can notice based on the shear force diagram SFD that the maximum shear force are applied on the points A and B presenting the hinges, and the maximum value of the shear force is V equal to Q multiplied by L divided by 2. And you can examine the shear force or the applied shear force for the other load cases in this table and in the other tables reflecting more load cases. Now for the cross-sectional shear force resistance VCRD, it's equal to VPLRD as it is depicted by the formula that you see now in this slide. PL refers to plastic in association with the plastic behavior of the considered steel beam, and RD refers to resistance design. The shear area AV, I will explain this next in this educational video, and Fy is the steel yield stress, and I explained how it is determined based on the steel grade and the thickness in the previous educational video, and gamma m0 is equal to 1 as I explained it in the previous video. So the shear force AV is determined based on the dimensions of the cross section of the steel beam based on the table that you see now in this slide. So depending on the steel member profile, we can determine the shear area AV using the formula that you see in this table. That's all for this educational video. Please, if you have any remarks or questions or suggestions, please mention it in the comments. Thank you very much for your attention.